Today we're covering the second part of section 7.5, trigonometric form of a complex number. We're going to start with the proof. We're going to look at the product of two complex numbers in trigonometric form. So we're going to take one complex number and call it z1. We're going to call the radius r1 and its angle theta1. And we're going to take a second complex number and call its radius 2 and its angle theta2. So thinking about the product, we can think about multiplying together the first complex number times the second complex number. So that would look like this. R1 cis theta1 times R2 cis theta2. And now to simplify this, I'm going to expand. Remember, CIS form just means cosine theta plus I sine theta. So I'm going to expand each one of these cis theta expressions. Well, now we've got two binomials to multiply together. And to think about multiplying these two binomials together, we can think about FOIL. So FOIL, first term times the first term, outer, inner, and last. And when we expand all of that, we get this really long expression. I'm leaving the R1 and R2 outside the set of parentheses. But here's the expanded form of those two binomials. And now I'm going to think about simplifying a little bit. I squared we can simplify to become -1. Both of these middle terms have an I in common, so I'm going to factor out the I. So in this step, I've moved this term over here, and I've factored an I out from the two middle terms. And now I'd like you to pause your video for a second, take a good hard long look at this expression, and see if you can recognize any familiar patterns. Maybe you recognized that these first two terms, the cosine of an angle times the cosine of a second angle, minus the sine of the first angle times the sine of the second angle, this is a formula that we've seen in the past. This is the cosine of the sum of those two angles. And again, here's another familiar pattern. The sine of a first angle times the cosine of a second angle, plus the cosine of that first angle times the sine of the second angle. This is another pattern that we've seen before. This is the sine of the sum of two angles. So we can simplify this expression to become the sine of the first angle plus the second angle. So we've taken this idea of the product of two complex numbers, and we have simplified it down to this, which is the general form for the product of two complex numbers in trig form. This is the formula that you'll see in your textbook, and here's our simplified form. Instead of writing out cosine plus I sine, we can write cis of the first angle plus the second angle. I'm not going to show the proof, but I'd encourage you to try the proof of the quotient of two complex numbers using the same thought process that we did here. Here are the two formulas from this section that I'd like you to know. Here's the product formula that we just proved, and here's its simplified form. And here's the quotient formula for dividing two complex numbers. You're going to divide the first radius by the second radius, and instead of adding the two angles, you'll be subtracting the two angles. The simplified form you can think of as R1 divided by R2 cis the first angle minus the second angle. Let's work through a couple of examples. We want to find the product of the two complex numbers. Well, using the formula that we just learned, z1 times z2, we can multiply r1 by r2, so that's going to be 2 times 8. I'm going to use the simplified version cis, the first angle, 2 pi over 3, plus the second angle. The second angle here is 11 pi over 6. And now all we have to do is simplify this. We have 16 cis. We can get a common denominator here by making this 4 pi over 6. So we can add now the 4 and the 11 and get 15 pi over 6. And typically you want your angle to fall between 0 and 2 pi. So we can simplify 15 and 6 are both divisible by 3. We can make this 5 pi over 2. And if we think about 5 halves on the unit circle, I know this is 1/2 pi, so this would be 2 halves, 3 halves, 4 halves. 5 halves is coterminal with 1/2 pi. 16 cis pi halves. If the directions ask you to leave your answer in trig form, you can leave it just like this. Otherwise, you can simplify to put it back in standard form. Here's a second example. We're asked to find z1 divided by z2 if our first complex number is 24 times the cosine 300 degrees plus I sine 300, and our second complex number is 8 times this. Well, we're asked to divide, so z1 divided by z2. We're going to take the quotient of the two radiuses, 24 divided by 8, cis, and then we subtract the two angles, 300 degrees minus 75 degrees. And simplifying, we get 3 cis 225 degrees. For example 3, we're asked to do a number of different things with the same setup. We have one complex number, -1 plus root 3i, and another complex number. So this form, remember, is standard form of a complex number. It's in terms of a and b instead of being in terms of r and theta. So we know that we're starting off in standard form. The first step asks us to find the product algebraically. Well, the product algebraically would just be multiplying -1 plus root 3i times 4 root 3 minus 4i. And we can FOIL to multiply, so -4 root 3. Outer would be plus 4i. Inner would be plus 4 times 3, 12i. And minus 4 root